Okay, hello grade 8 and welcome to your review on volume. There's only 10 questions in this particular chapter, so pay close attention to the details of what you should have done so that on the retest, if you decide to do that retest, you don't do so bad. The first question is a true-false question. It says volume of any right prism can use the formula area of the base times the height of the prism. That is true. That is our formula for any right prism, whether it be a cube, a rectangular prism, a cylinder, or a whatever the other one I didn't say was. They will always work. So if it's area of the base times the height of the prism, if it's a rectangular prism, it will be length times width, which is the area of the base, times the height. If it's a cube, it'll be side squared, which is the area of the base, times height. If it's a triangular prism, it's base times height divided by 2, which is the area of the base, times a capital H. And the reason why we use a capital H is to differentiate between the two, because in a triangular prism, this is the capital H, and this is the small h. And if it's a cylinder, it'll be pi r squared, because a cylinder has a circular base times the height of the prism. So it is true. All of these formulas here fall under the category of area of the base times the height of the prism. Question 2, a cube with a base of 64 centimeters squared. And this is supposed to be changed with 3. It was a misprint. So a cube with a base of 64 centimeters squared. So the base is 64 centimeters squared, and it's a cube. That means it was a square. And if it was a square and its area was 64 centimeters squared, that must mean that the edge length is 8 centimeters. Okay? So if the 8 centimeters and 8 centimeters are here, since it's a cube, this must have also been 8, and 8 times 8 times 8 equals 512, which makes this a true statement. It doesn't care, but it is true, so it's okay. So 25% of you were wrong with that question. Question 3, 100% of you said true, which is true. 1 cubic centimeter of water, which in our class was one of those yellow cubilinks or orangey yellow cubilinks. And we said that one of those, if it was made of water instead of plastic, would have a volume of exactly 1 milliliter. That's where we base our metric system from. We base it from water. And we also know that 1 cubic centimeter of space has 1 milliliter of liquid volume if it's water, but also it has a mass of exactly 1 gram. And that's where we base our metric system for measuring of weight. A kilogram is 1,000 milliliters, or a liter of water. That's where we get the measurement of a kilogram from its relationship to water. Question 4, changing the orientation of a prism affects the volume. Now remember, orientation is simply a fancy way, if I can take this, a fancy way of saying this. So the orientation is rotated. Does that affect the volume? No, because the amount of space inside it doesn't change. What would change would be the actual area of the base, but when you multiply it out, so here it's length times width times height, and here it's length times width times height. Here the base is made up of a rectangle that's 4 by 5 or 5 by 4. The height is 10. Over here, the length and width would be 4 times 10 times the height, which is 5. When we work out the math, we get 200 centimeters cubed as the volume here. And over here, we also get 200 centimeters cubed. So even though we probably knew that the volume doesn't change if you rotate the box, using the formula, it does prove that the volume does stay the same. Question 5, what is the volume of this cube? Our formula, area of the base times the height of the prism. Since the base of a cube is a square, we will use the formula side squared to represent the area of the base, times the height of the prism. Since all sides are equal in measure, 5 squared times 5 is 25 times 5, which is 125 meters cubed. Some other people say you could also use the formula side cubed, and that's why we say an exponent of 3 we sometimes refer to as being cubed. That's because it is the volume of a cube, because it has 3 dimensions. Question 6, what is the volume of this rectangular prism? Well, the area of the base is a rectangle, so we'll use length times width. The height is h. It's 100 times 5 times 25, or 500 times 25, which is 125 plus 2 zeros. 12,500 cubic meters is how much space is inside that rectangular prism. Question 7, what's the volume of this triangular prism? A lot of people get this wrong. And what I'm going to do is I'm going to rotate this. I'm going to change its orientation to make it a little bit easier maybe. So if I bring it down like that, I can now see this triangle a little bit better. The face is like this. And that's its base. So the base of any triangular prism is a triangle. If I put in the measurements, it's 3, 18, and I don't care what these two measurements are because that does not affect the area of the prism. The area or of the triangular face. Base times height divided by 2. I know my base and I know my height. 18 times 3 is 54. Half of 54 is 27. So the area of the base, this base here of a triangular prism, is 27 meters squared. The height of the prism is 10. So when I multiply that out, I get 270 meters cubed as the capacity or the volume of this triangular prism. In the remote it said 540, but the actual answer is 270. 270. Question 8, what is the volume of this cylinder? Again, area of the base, since it's a circle, we'll use pi r squared times the height of the prism. It says use 3 as pi, so we'll use 3 as pi. 3 times, since the diameter is 10, the radius will be 5. So when we substitute the information, that's what it looks like. 3 times 25 times 2 is 75 times 2, which gives us a volume of 140, or 150, excuse me, centimeters cubed. Question 9. A cube has a volume of 64 centimeters cubed. What is its edge length? Well, this asks you to kind of use a little bit of trial and error, unless you know that the cube root of that would be the edge length. But since we know that side squared times h is the formula, and we know that's 64, then we have to think, well, what could these be? Now, we know they're all going to be the same number, so we'll start with 8. We'll try 8 squared times 8 and see if that equals 64. Well, 64 times anything is not going to be 64, so we're going to erase that and say, nope, it's not that. So trial and error says, let's try 3. That's going to be 9 times 3, which is 27, not 64, but we're getting closer. If we try an edge length of 4, 16 times 4 is 64, which means this has to be 4, this has to be 4, and this has to be 4 to give it a volume of 64 cubic centimeters, which means, what's the edge length? The edge length is 4 centimeters. Now, what you also could have done, instead of using side squared times h as your formula, remember what we said earlier in the video, that that's the same thing as side cubed. So if I said side cubed equals 64, on my calculator, we all know, we're familiar with the square root button. It's right here, right? You can't square the root 0. But if I put 64 and hit this button right here, the cube root, it will calculate the cube root of 64 as being 4 for me, right? Oh, that's not right. I hit the wrong button. Oops. Let's try that again. 64, where's the cube root button? Oh, it's right here, sorry. Cube root button's right next to it. Cube root button is 4. And it actually says the word cube root right there. So the cube root of 64, meaning what number multiplied by itself 3 times, is 64, and the answer is 4. And the last question is, a rectangular prism is 2/5 full of water. How much water is in the prism? Well, if we look at this one, there's 2 ways to really do it. You could first find the full volume, and then take 2/5 of the full volume. And the other way we could do it is, if the height is 14, take 2/5 of the height, and then calculate smaller volume. So we're going to do it both ways to show you what it looks like. So if I find a rectangular prism's volume, I use length times width times height. that would be 18 times 8 multiplied by 14. 18 times 8 is 144 times 14. That I can't do in my head very quickly. So 144 times 14 equals 2016. So if it was completely full, it would have a full volume of 216 cubic centimeters. I would then say, well, what's 2/5 of 2016? It's easier to use decimals than it is fractions. So since 2/5 is the same thing as 0.4, I'd much rather work with decimals than I would fractions. So take 2/5, which is 4/10, times 2016 equals 806.4. And since we're talking about water, we can actually say centimeters cubed, or going back to our true-false question, we could say that it's 806 milliliters, or 4/5 of a liter of water could fit inside there, or in that 2/5 full. Somebody said before, he said that's not, if it's 2/5, it should be less than half. And you're right, it should actually be less than the halfway. And that looks like it's about 4/5 full, not 2/5, but whatever. The other way you could do it says, what's 2/5 of 14? Because if the full height is 14 centimeters, 2/5 full would mean it's 2/5 of the height. And if I think about that, it's 28 over 5, which is 5 3/5, which as a decimal is 5.6. So I could say that if it's 2/5 full, that height is 5.6. Then if I go length times width times height, instead of using the full height, I'll use the 2/5 height. 18 times 8 times 5.6, if I take my calculator. 18 times 8 times 5.6 equals the same answer I got before, 806.4 milliliters of water are inside there. So it's up to you which way to do it. Most students find calculating the full volume and then 2/5 easier. Some students like to find 2/5 of the original height to figure out what the volume is of the water. It's up to you.